At the heart of the Milky Way, far beyond the reach of any human journey, there exists a region where the universe folds in on itself, a place where distance loses meaning, where time no longer behaves as it should, and where light, normally the fastest thing that exists, simply stops. This is not myth. This is not theory alone. This is Sagittarius AE. Invisible to the eye, yet undeniable in its influence, Sagittarius AE holds a mass more than 4 million times greater than that of the Sun, compressed into a volume smaller than the orbit of Mercury. It does not shine. It does not announce itself. Its presence is known only by what it does to everything around it. Stars near the galactic center move at impossible speeds, whipped into tight, violent orbits around an object they can never see. Gas clouds stretch, spiral, and vanish. Space itself bends inward, as though the galaxy were breathing toward a single silent wound. This is a supermassive black hole, not an object in space, but a distortion of space. To approach it is to approach the limits of reality. There exists a boundary around Sagittarius A, an invisible surface called the event horizon. It is not made of matter. There is nothing to touch, no wall, no shell, no warning. And yet, crossing it marks the end of all possible return. Any light that passes this threshold is trapped forever, dragged inward by gravity so intense that escape is no longer a concept that applies. Within roughly 12 million kilometers of this boundary, space curves so violently that all paths point inward. Forward motion becomes indistinguishable from falling. The universe itself seems to tilt. Beyond the event horizon, the laws that govern existence outside simply no longer apply. Black holes are born from death. They mark the places where the most massive stars once burned with unimaginable fury, fusing atoms in their cores, pushing outward against gravity with nuclear fire. For millions of years, these stars hold a delicate balance, outward pressure versus inward pull. But balance is temporary. Fuel runs out, fusion slows. Gravity, patient and relentless, finally wins. When that collapse begins, there is no stopping it. For smaller stars, quantum forces step in. Matter resists compression. White dwarfs form. For heavier stars, even stronger resistance arises, neutron degeneracy pressure, forcing protons and electrons to merge into neutrons. A neutron star is born, a city-sized object with the mass of the Sun, where gravity is so strong that mountains cannot exist, and atoms are crushed into a dense, seething ocean of particles. On the surface of such a star, gravity is more than 100 billion times stronger than on Earth. Anything that falls onto it is obliterated instantly, flattened and absorbed into matter so dense that a teaspoon would outweigh entire mountain ranges. If a human body were somehow placed there, it would not fall, it would be compressed. The spaces inside. Atoms would collapse, electrons would be forced into nuclei. Every structure that defines flesh, bone, and thought would be erased, replaced by a frantic near-light-speed dance of neutrons fighting for space. And yet, even this has a limit. Add just a little more mass, just a fraction beyond what neutron pressure can support, and gravity takes full control. The neutron star collapses. Space and time themselves are dragged inward, forming a singularity, a point where density becomes infinite, where curvature becomes absolute, where the future ends. One cosmologist once described the Big Bang as a day without a yesterday. A black hole singularity is its mirror, a moment with no tomorrow. What remains is not a star, not a corpse, but a shadow carved into reality itself, a black hole. Gravity is not dramatic. It does not roar or strike. It simply pulls, always, quietly, relentlessly. Even now, it pulls you downward through the floor toward the center of Earth. You do not fall, because the structure of matter resists it. The illusion of solidity protects you. But that illusion is fragile. Matter feels solid, but it is mostly emptiness. Atoms are vast spaces held together by electric forces. Electron clouds repel one another, preventing collapse. This balance is enough to support planets, mountains, even stars, up to a point. Beyond that point, gravity rewrites the rules. As black holes form across the universe, at the centers of galaxies in the aftermath of stellar collapse, They become markers of extremity, boundaries where knowledge ends, laboratories of physics pushed to breaking. For centuries, humanity believed space and time were fixed, absolute, a silent stage on which matter moved. Isaac Newton imagined a universe where gravity acted instantly across distance, where time ticked forward identically for all observers forever. That vision endured until it shattered. In the early 20th century, a quiet revolution began. Albert Einstein proposed something radical. Space and time were not separate. They were not rigid. They were part of a single, flexible fabric, spacetime, capable of stretching, compressing, and bending. The speed of light exposed the lie of absolutes. Light travels at the same speed no matter how fast you move. Run toward it, chase it, flee from it. It does not change. To preserve this strange fact, space and time themselves must adjust. Length contracts, time slows, reality reshapes itself to obey a deeper rule. Experiments confirmed it. Atomic clocks flown around the world tick differently than those left behind. Particles near the speed of light experience distances that simply did not exist for stationary observers. Time itself proved negotiable. Then came Einstein's final revelation. Gravity was not a force pulling objects through space, it was space itself bending. Mass tells spacetime how to curve. Curved spacetime tells matter how to move. Stars, planets, light, everything follows the geometry laid down by mass and energy. Near Earth, the curvature is gentle. Near neutron stars, extreme. Near black holes, absolute. Light bends, time slows, paths converge. Near an event horizon, space-time curves so violently that all futures lead inward. To an outside observer, an object falling toward a black hole appears to slow, freeze, and fade, its light stretched into invisibility. But to the falling object, time flows normally. The crossing is unremarkable. And that is the most terrifying truth of all. There is no moment that announces the end, no sensation that signals the crossing, only the quiet certainty that every possible future now lies behind you. The universe allows the fall. And at the center of every galaxy, including our own, this silent process continues, stars circling, matter vanishing, space-time folding inward, while the rest of the cosmos looks on, unaware. The shadow remains, unmoving, unquestioning, patient, to fall toward a black hole is not to rush into destruction. It is to drift into distortion. Far from the event horizon, space still behaves almost normally. Stars orbit, light travels, time flows with familiar rhythm. But as one moves closer to the black hole's center of influence, subtle changes begin. Changes so slight that no single moment announces them, yet so profound that reality itself starts to unravel. Time is the first to suffer. According to general relativity, gravity does not merely pull matter, it slows time. Near massive objects, clocks tick more slowly than they do far away. On Earth, this effect is tiny but measurable. Near neutron stars, it becomes dramatic. Near black holes, it becomes absolute. For an observer watching from a safe distance, an object falling toward the event horizon appears cursed. Its movement slows, its signals stretch. Each pulse of light takes longer to arrive than the last. Colors redden, slipping beyond visible wavelengths. Eventually, the object seems to freeze in place, suspended just above the horizon, fading into darkness. It never crosses. But this is an illusion. For the falling object itself, time flows forward without pause. There is no freeze, no hesitation, no warning. The event horizon is not a physical surface. It does not burn, shock, or repel. Crossing it feels no different than drifting through empty space. The trap is already closed. Inside the horizon, all directions point inward. Forward and down become the same. No force, no engine, no signal can alter the outcome. Escape velocity exceeds the speed of light, not because the black hole pulls harder, but because spacetime itself is tilted so steeply that light has nowhere else to go. At this point, the universe outside becomes unreachable, not merely distant, but causally disconnected. Every event beyond the horizon belongs to a past that can no longer influence the present. The future narrows into a single destination, the singularity. As the fall continues, tidal forces grow stronger. Gravity does not pull evenly. The difference in gravitational strength between head and feet becomes extreme. This effect, known as spaghettification, stretches objects into long, thin forms as atoms are pulled apart by unequal forces. For stellar mass black holes, this stretching is immediate and violent. Molecules are torn apart long before the horizon is crossed. Matter is shredded, reduced to streams of particles spiraling inward. But supermassive black holes, like Sagittarius A, are different. Their immense size spreads tidal forces over vast distances. An object could cross the event horizon intact, unaware of what has happened. The true destruction comes later, deeper inside, where curvature becomes extreme. Here, time behaves in ways that defy intuition. Inside the horizon, time and space exchange roles. What was once a direction becomes a moment. What was once a moment becomes a direction. The singularity is not a place you can avoid, it is a time you cannot escape. Just as you cannot stop tomorrow from arriving, you cannot stop the singularity from approaching. In this region, the concept of remaining alive loses meaning. Physics no longer offers stable states. Structures cannot persist. Forces that once held matter together are overwhelmed by spacetime itself, collapsing inward. And yet, even here, uncertainty remains. The equations of general relativity predict the singularity, an infinite density, zero volume, infinite curvature. But infinities are warnings, not answers. They signal the failure of a theory pushed beyond its domain. At the singularity, general relativity breaks. Quantum mechanics, the framework governing particles and probabilities, also breaks. The two great pillars of modern physics collapse into contradiction. This has led some physicists to propose that singularities may not exist as predicted, that some unknown quantum structure intervenes, that spacetime does not end but transforms. Perhaps matter is compressed into exotic states, perhaps spacetime tunnels elsewhere, perhaps information is preserved in ways not yet understood, or perhaps not. What happens beyond the singularity remains the deepest unknown in physics, not because it is hidden, but because it is fundamentally unreachable. No signal can return, no observation can confirm or deny. The interior of a black hole is forever sealed from external knowledge. This creates a paradox that haunts cosmology. If information falls into a black hole and is destroyed, then the laws of quantum mechanics are violated. If it is preserved somehow, then where is it stored? On the horizon, encoded in radiation, dispersed across spacetime? Black holes force the universe to confront its own contradictions, and they do so silently. Across the cosmos, supermassive black holes sit at the centers of galaxies, shaping stellar orbits, regulating star formation, and anchoring immense structures. They are not rare anomalies. They are fundamental components of cosmic architecture. They are both creators and erasers. Without them, galaxies may not form. With them, nothing is safe forever. As humanity peers deeper into the nature of black holes, a troubling idea begins to emerge, not as speculation, but as consequence. If black holes represent the ultimate expression of gravity, then gravity is not merely a force of attraction, it is a force of erasure. And at the heart of every galaxy, including our own, that erasure continues, slowly, patiently, pulling spacetime inward, reshaping the future of everything that dares to exist nearby. As understanding of black holes deepened, scientists were forced to confront a question far more disturbing than gravity, time, dilation, or even destruction. Does the universe remember? At first, this seemed philosophical, almost poetic. But the question was mathematical, physical, unavoidable. If black holes consume matter completely, if everything that falls beyond the event horizon is lost forever, then something fundamental breaks. Not just information, but causality itself. In quantum mechanics, information cannot be destroyed. Every particle interaction preserves data about what came before. Even chaos is reversible in principle. Smash a glass, and while it seems lost to disorder, the information about its original structure still exists. encoded in the positions and energies of every fragment. Black holes threaten this principle. If matter falls into a black hole and disappears into a singularity, then its information is erased from the universe. The past is severed, because no longer leads to effect, reality forgets. This contradiction became known as the information paradox, and it exposed a fracture between the universe's deepest laws. Gravity, described by relativity, permits erasure. Quantum mechanics forbids it. Both theories are correct, yet they cannot both be right in this context. Something had to give. The resolution, when it began to emerge, was more unsettling than the paradox itself. Black holes, it seemed, do not erase information, they hide it. The event horizon, once thought of as a point of no return, became something else entirely, a boundary of storage. A surface where information is not lost but encoded. Every particle that falls in leaves an imprint, not inside the black hole, but on its surface, smeared across the horizon like a cosmic shadow. This led to a shocking realization. The interior of a black hole may not matter as much as its boundary. In this view, the event horizon acts like a vast two-dimensional ledger, recording the properties of everything that crosses it. Mass, charge, spin, all reduced to subtle distortions in space-time geometry. The black hole becomes less like a hole and more like a memory device, compressing the history of everything it has consumed into an impossibly dense record. Reality, it turns out, may be holographic. This idea, that the universe itself may encode information on lower dimensional boundaries, did not arise from black holes alone. It echoed through theories of quantum gravity, string models, and cosmological simulations. Space may not be fundamental. Volume may be an illusion. What we perceive as three-dimensional reality could emerge from information stored on distant surfaces. If true, then falling into a black hole does not erase you, it flattens you into data. But this does not restore comfort, because even if information is preserved, experience is not. Whatever crosses the horizon never returns. Its future is sealed. Its story ends even if its information lingers, encoded beyond retrieval. Preservation without access is indistinguishable from annihilation, and yet black holes do not keep their secrets forever. Over timescales longer than the age of the universe, black holes slowly lose mass. Through a quantum process known as Hawking radiation, they leak energy into space. Faint, thermal emissions that carry no obvious structure. As the black hole shrinks, this radiation increases until eventually the black hole evaporates completely. If information is stored on the horizon, then evaporation raises a terrifying possibility. The black hole may release what it consumed, but in what form? The radiation appears random, featureless, a hiss of energy without pattern. If information is encoded there, it is so thoroughly scrambled that reconstruction becomes practically impossible. The universe remembers, but only in fragments so disordered that meaning is lost. A book burned to ash still exists, chemically, but its story is gone. This leads to a deeper, darker implication. If black holes preserve information only in a way that no observer can recover, then memory without meaning is the universe's final state. History exists, but no one can read it. Causes happened, but effects are gone. The universe does not forget, but it does not care to. Remember, this revelation ripples outward beyond black holes, beyond galaxies. If reality itself is built from information, then existence is not defined by matter or energy, but by structure, patterns, relationships, order held briefly against entropy's tide. And entropy always wins. Civilizations, like stars, are structures. Consciousness is a structure. Meaning itself is a structure. All structures decay. Black holes are not monsters lurking in space. They are the universe expressing its most fundamental tendency, the compression of complexity into simplicity, the reduction of distinction into uniformity. In this sense, black holes are not anomalies. They are destinations. The universe does not end in fire or collapse. It ends in flattening, in information dispersed so evenly that no difference remains, no contrast, no signal, no story. And yet, within this bleak framework, a fragile miracle persists. For a brief span of cosmic time, matter organizes itself into minds, capable of asking these questions, of fearing erasure, of seeking permanence in a universe that offers none. Black holes do not destroy meaning, they expose its limits. They show that the universe can record everything and still render it irrelevant. That memory alone is not enough, that without observers, information is just noise. And somewhere, at the center of every galaxy, the shadow continues to grow, not as a threat, but as a reminder. Nothing is ever truly lost, but nothing is ever truly saved either. If black holes revealed that the universe preserves information without preserving experience, then the next realization was even more destabilizing. Observation itself may be a temporary privilege, not a fundamental feature of reality. For centuries, humanity assumed that the universe existed in a definite state, whether it was observed or not. Stars burned, planets orbited, time flowed, independent of eyes or instruments. But as physics pushed closer to the limits, imposed by black holes, a quieter truth emerged. At the deepest levels, reality does not simply exist. It resolves. Particles do not occupy fixed positions. They exist as probabilities. Outcomes crystallize only when interactions occur. Measurement does not reveal reality. It creates a version of it. And black holes, by sealing regions of spacetime from interaction, create zones where resolution never completes. Inside an event horizon, there are no observers, no measurements, no shared frame of reference. The interior becomes a place where questions cannot be asked, not because answers are hidden, but because the act of questioning itself is impossible. Meaning requires comparison. Cause requires continuity. Experience requires a future that can be reached. None of these survive past the horizon. This realization transformed black holes from exotic objects into something far more profound, boundaries of meaning. Beyond them, physics may continue, information may persist. But interpretation collapses. Reality loses narrative. As cosmologists extended this insight outward, a disturbing parallel appeared. The accelerating expansion of the universe, driven by dark energy, creates horizons of its own. Not physical surfaces like event horizons, but cosmic horizons, distances beyond which information will never reach us, no matter how long we wait. Light emitted today from sufficiently distant galaxies will never arrive. Space between us stretches faster than light can cross it. These regions are not merely far away, they are permanently unreachable. The universe is dividing itself. Over time, more and more of reality slips beyond contact. Galaxies vanish from view. Structures dissolve into isolation. Each region becomes its own island of causality, sealed off not by walls but by expansion itself. In the far future, any observers that remain will inhabit a shrinking bubble of accessible universe. Outside it, existence continues, but without connection, without shared history, without mutual awareness. A cosmos full of things that exist but cannot be known. This mirrors the interior of a black hole on the largest possible scale. Both are realms where information may exist, but meaning does not propagate, where structure persists without story, where reality continues without witness. The universe, it seems, does not prioritize understanding. It permits it briefly. This reframed humanity's place in a way no previous discovery had. Life is not just rare because conditions are fragile. It is rare because windows of knowability are temporary. Consciousness arises only during narrow intervals where complexity can form and persist long enough to reflect. Outside those intervals, before stars ignited after they fade, there may be no observers at all. The universe exists, but never knows itself. In this light, intelligence is not an endpoint of evolution. It is a phase, a transient configuration of matter that allows reality to be examined before conditions erase the possibility. And black holes stand as the ultimate reminder of this truth. They are not merely destroyers of matter, they are destroyers of perspective. They demonstrate that the universe can continue perfectly well without experience, without memory that can be accessed, without meaning that can be shared. Even time itself becomes suspect. Near horizons, both black hole and cosmic, time stretches, fractures, and loses coherence. Different observers disagree on the order of events. Futures diverge. Pasts become unreachable. The notion of a single universal timeline dissolves. Reality is not one story. It is many partial stories that overlap briefly before drifting apart forever. And yet within this fragmentation, one final question emerges. Quiet, unsettling, and impossible to ignore. If meaning requires observers, and observers are temporary, then meaning itself is temporary. The universe does not care whether it is understood. It does not strive toward complexity or awareness. Those arise as consequences, not goals. When conditions allow, matter organizes into stars, into planets, into minds. When conditions change, those structures fade, leaving behind only traces too scattered to reconstruct. Black holes do not erase meaning because meaning was never guaranteed. They simply reveal the rule that governs everything. Nothing that requires context can last forever. And so the universe continues its slow transformation, not toward chaos alone, but toward silence. A silence not of emptiness, but of inaccessible abundance. A reality rich with information, poor in understanding. For a fleeting moment, there were beings who could see it, question it, fear it, and wonder at it. Then the horizons closed. When the last horizons close, the universe does not end. It simply continues without perspective. Long after galaxies have slipped beyond reach and the night sky has emptied of distant light, reality persists. In a stripped-down form, matter, energy, space-time, all obeying the same ancient equations, yet doing so without reference, without comparison, without meaning attached. The universe becomes a system that no longer needs to be understood in order to function. Stars still burn for a while. Red dwarfs linger, dim and patient, consuming their fuel with extreme caution. Around them, frozen worlds drift in silence. Any remnants of life that endure do so under extreme constraints, clinging to dwindling energy gradients, evolving slowly, if at all. But even these holdouts are temporary. Stellar fusion is finite. Entropy never forgets. Eventually, the stars go dark, not with explosions, not with collapse, but with exhaustion. The last light fades, and the universe enters an era dominated by objects that no longer shine. White dwarfs cooling toward invisibility, neutron stars spinning down into stillness, and black holes reigning alone over vast stretches of empty space-time. In this era, time stretches into something nearly meaningless. Events still occur, but at rates so slow that cause and effect blur together. Motion becomes rare. Interaction becomes improbable. The universe settles into a long, quiet decline, a drawn-out fading rather than an ending. Black holes become the final architects of structure. They drift through expanding space, occasionally merging, occasionally swallowing stray particles. Their gravity still curves space-time, still governs motion, but there is no audience to observe it. No clocks to tick differently near their horizons, no questions asked about what happens inside, and then, even black holes begin to fail. Through subtle quantum processes, they lose mass. Particle by particle, energy leaks away. Hawking radiation whispers into the void, weak, diffuse, almost meaningless. Over unimaginable spans of time, longer than any star's lifetime by factors that defy comprehension, black holes evaporate. When the last one vanishes, the universe crosses a boundary more final than any horizon. No massive objects remain, no stars, no planets, no black holes. Only an ocean of low-energy particles drifting apart as space continues to expand. Temperature differences flatten, motion approaches stillness. The universe approaches thermodynamic equilibrium, a state where no useful work can be done, where change has no direction. This is not death, it is completion. And yet, Even here, physics does not quite end. Quantum fluctuations continue. Tiny disturbances ripple through empty space, appearing and disappearing without cause or consequence. Most vanish instantly. Some persist for a fraction longer. In extremely rare circumstances, given enough time, one fluctuation may grow instead of fade. The mathematics allows it. A region of space could inflate, space-time could separate, a new universe could be born. If this happens, it does not happen within the old universe. It happens from it, a branching without memory, without inheritance, without continuity. No information passes between them. No story survives the transition. The new universe begins clean. No witnesses, no record, no awareness of what came before. Creation without remembrance. If this cycle repeats, if universes give rise to others through rare quantum events, then existence itself is not linear. It is iterative, producing countless isolated realities, each self-contained, each temporary, each alone. In this framework, the universe does not seek to preserve meaning. It seeks only to obey its equations. Awareness arises incidentally, not intentionally. Consciousness is a side effect of favorable conditions, not a goal encoded into reality. Meaning is local. Understanding is fragile. Witnesses are rare. And yet, for a brief interval in one universe, on a small planet orbiting an ordinary star, matter assembled into beings capable of looking outward and grasping these truths. They observed the shadows at galactic centers. They measured time bending near gravity. They realized that the universe could continue without them, and had done so long before they existed. They understood that existence does not promise purpose, only presence. That moment of understanding mattered, not because it altered the universe, but because it allowed the universe to be known, however briefly. A spark of awareness in a system otherwise indifferent to its own structure. When the last observer fades, nothing catastrophic occurs. The equations do not change. Space continues expanding. Energy continues dispersing. Reality continues unfolding exactly as it always has. But the universe becomes what it was for most of its existence and will be again. A vast, silent process without witnesses, without memory, without meaning assigned. And still, it endures.